Hello, this is Flipped Notes 1.6, and we are looking at correlational studies. So far, we've been looking at observational research, and this still falls under descriptive and observational research. We're not to experiments yet. So the big thing here with all the others we've had so far is we cannot determine any kind of causation yet. Only can describe and observe. We can't determine causation until we start getting into experiments. So descriptive statistics, correlations, whenever two variables are related to each other, they are correlated. So we could be talking about anything like the number of people in a class and how it correlates to average GPA, or the number of cars on the road and how that compares to travel time to a destination. So anytime we have two variables and we're looking at how they relate to each other, we have a correlation. We can measure how much they are correlated with a numerical index of their degree of relationship. It is always going to be expressed as a number between 0 and 1, and that includes 0 and -1, but it will never be above 1 or -1. We can say a correlation is positive or negative, and we don't mean good or bad. We just mean the direction of the relationship. But generally, if it is closer to 0, it is a weak relationship. And if it is closer to 1 or -1, it's a stronger relationship. So, for example, in a positive correlation, two variables will increase or decrease together. So they're moving at the same direction. It could be decreasing, but they're both going in the same direction. So, for example, the number of gallons of gas pumped is positively correlated to the amount spent on gas. The more gas you pump, the more money you'll spend. The less gas you pump, the less money you'll spend. That's a positive correlation. In a negative correlation, the two variables move in opposite directions. For example, miles traveled is negatively correlated to the amount of gas left in your tank. The more miles you drive, the less gas you have left. You drive fewer miles, you have more gas left. As one goes down or decreases, the other one increases. That's a negative correlation. We can show how strong the correlation is by looking at the correlation coefficient, and it's represented by the letter R. So when we're looking at the statistical measure of the relationship between two variables, we're going to use R. So R is going to equal anywhere between 0 and 1 or 0 and -1. So here we've got R equals positive 0.37. So the R represents relationship. The positive number indicates that it's a positive correlation, and then the 0.37 tells us the strength of the relationship. It would also tell us how much of a slope if we were going to graph this. So, and we'll talk more about those coefficients here in a minute. So some more examples here, looking at it in terms of using directional arrows. So high scores on X are associated with high scores on Y. So for example, the higher your high school GPA can predict a higher college GPA. The lower your high school GPA, the lower your college GPA. So they're moving in the same direction. Now, and we're going to get into this even more here in the same lesson, but that does not mean they cause each other. A high school GPA does not cause a college GPA. It's a good predictor for it, that the higher your grades in high school predicts higher grades in college, but not necessarily. Lower high school grades can predict lower college grades, but there's a lot of other variables in there. Do you go to class? Do you have a job? How much do you like to sleep? How well do you do on tests? How harder are the courses at a different school? So there's a lot of other variables, but these two can correlate together. In a negative correlation, remember, one increases and one decreases. As the number of absences from class increases, it correlates with lower exam scores. Lower exam scores fewer absences from class correlates with higher exam scores. So the direction just is in the opposite direction. Sometimes it's really just how you word it, because sometimes it could be very similar, the correlations, it just depends how you word it. All right, so here we're looking at the strengths of the relationship with those correlation coefficients, again represented by R. So earlier we had the example of R equals positive 0.37. So that would be about here on the scale. So that would be between a low and a moderate correlation. We see that the higher the number, the correlation coefficient, the stronger the relationship. But it could also be a strong relationship even if it's negative. So for example, a negative 0.97 is a stronger relationship than say a positive 0.2 because 0.2 is closer to 0. When the coefficient is closer to 0, there's very little relationship to the variables and it's hard to predict one with the other. So going to the right, that's our positive correlations. To the left are negatives. Moderate correlation right around that 0.5 or negative 0.5 range. So we can also graph correlation coefficients by using the different points of data that we're given. And then we can look at the relationship based on the slope of the line. It's a little bit hard to see the dots on here, but a perfect positive correlation of +1 is going to have an upward sloping line. A perfect negative correlation of -1 is going to have a perfect negative sloping line. And if there's no correlation, the dots are just going to be kind of all over the place. We'll look at some more examples of these in class. All right, another example here showing height and temperament in people. When we say temperament, we kind of mean like how easy to anger somebody is. So is there a correlation between their height and how easily upset they get? So the scatter plot took the data that was on the previous slide and it graphed it. So we had 20 points and it shows that there's a moderate positive correlation of plus 0.63. So that means height does seem to correlate with temperament, that the taller somebody is, it seems that they get angry a little bit easier. Now, you can tell this is a positive correlation because if we were to try to connect the dots, they're gradually going upward. If this was a perfect correlation, the dots would be closer to the line of being a perfect 1.0. But because it's only plus 0.63, they're still scattered a little bit. So there's not a perfect slope there, but you can tell that there's an upward trend. So that's positive 0.63. So the key thing to remember with correlations is that correlations help us to predict what's going to happen with the next variable, but it can't tell us what causes it. There's too many other factors. But the higher the correlation coefficient, the better our ability to predict the other one. Another example, SAT and ACT scores are moderately correlated with first-year college GPA. So again, they're a pretty good predictor of how well you're going to do your first year of college. But they cannot say having a high SAT or ACT score causes you to have a high GPA your first year of college. There's so many other variables involved. It can help predict, but it can't tell us it caused it. It is possible for two variables to be very highly correlated, but not causally related, meaning they go together, but one does not cause the other. So for example, there is a high correlation between foot size and your vocabulary. So for example, the bigger your shoe size and your foot size, it seems you have a greater vocabulary. Does that mean your foot size caused you to have a greater vocabulary? No. So do larger feet cause larger vocabularies? No. There's a third variable. In this case, it's your age. The thing that causes your greater vocabulary and greater foot size is your age. So correlation does not equal causation. Just because they correlate and they can predict each other does not mean it causes it. But the stronger the correlation, the better the chance at predicting it. There's just too many other variables that can be correlated without necessarily telling us why or how they're related. For example, low self-esteem can predict depression. Depression can also predict low self-esteem. They correlate together. But distressing events or biological predisposition, both of those can also correlate and predict low self-esteem and depression. So we can't necessarily say that one or the other is the cause, but we can definitely say that they're involved and that they are predictors. Some more example, and again, we're using that word predict instead of causes. Longer hair length predicts more shampoo needed. Shorter hair length predicts less shampoo needed. So the length of hair predicts the amount of shampoo needed, but could there be other variables that affect how much shampoo you need? Yes, there could be how thick your hair is, or how dirty the hair is, Or if the shampoo is not really very good, if it's kind of real watery shampoo, maybe you need to use more of it. So just because there's a correlation, again, doesn't mean that one causes the other. Longer hair length does not cause you to need more shampoo, but it does predict that you will need more shampoo. A negative correlation here, this is my real life, more time spent watching TV correlates with less time to grade papers. Less time spent watching TV can correlate with more time to grade papers. So that doesn't mean that one causes. Just if I watch less TV, that doesn't mean necessarily that I'm going to have more time to grade papers, because I could use that time doing something else instead. But it is a good predictor. So again, correlation does not equal causation. It predicts, but we can't say that one causes the other. That's it for flipped 1.6.